All right, good deal. We are up to 3 cameras, if you count mine too. Awesome. Thank you, brave people. All right, let's see. Yep. Let's see. Question: is it possible to have a method call another method in the same file? Yes, absolutely. And if you're calling a method in the same file, I'm thinking you mean class, yeah, you can just use the method name. And it works just like, in C, you're just calling another chunk of code, and you can pass variables as arguments and so on and so forth. I used to work with someone who not only would warm up plates of lasagna at their desk, but they actually had like a popcorn popper from a movie theater they worked in, and they would make fresh popcorn every afternoon at 3, and that was pretty cool. Yeah, I don't think I could do that in the STEM building. There's probably some rule against popcorn makers. All right. Questions so far? Hey, we could put one in the nerd cave. That would be awesome, actually. So I downloaded repos from PA-A and either posted a 10 out of 10 or posted a 0 and sent you a message explaining the problem. And you definitely want to get PA-A, squared away, because that's the repository in which you're going to do all of your submissions. So if that's not working, then it's not going to work for the others. Um, so if you didn't get 10 out of 10, right, go back and recheck your submission, check the spelling on the repository, make sure I'm added as a reporter, make sure you're on GitLab and not GitHub, make sure you're not in a parallel universe, etc., etc. All the usual stuff. Yeah, I miss the STEM building too. And I just got email this morning that Angela is leaving. I don't know how many of you remember Angela, um, who was in that front desk area, right, that you'd pass as you were going into 155. But she's taking a promotion and switching over to the nursing area. So that's a big loss for the STEM program, but really good for her and good for nursing. Yeah, those elevators were funny when they first opened the building because the floor numbers were off by 1. It was really confusing. I think the basement was floor 1 and the floor you walked in on was floor 2. And so you'd see people just like riding it up and down all day trying to figure out where to go. These are the upsides of lockdown, I guess. No elevators. All right. So any questions? Hopefully, people have started working on the fraction class and made some progress. I know that teachers love to tell you this, but I'm serious. This is not an assignment that you can rip through in one day. If you haven't done Java, if you haven't done object-oriented coding before, it's really a mental adjustment. And if you try to do this in one day, you're going to be writing C and Java, and it's going to be frustrating. It may not be very successful, and it's not going to do anything to prepare you for PA2. And PA2 is a really intense assignment where we're going to be putting a bunch of different classes together and making a new class that combines linked lists and hashes and all kinds of other stuff. And so we really want to be spending, this week um, and last week, to whatever degree you could, working with this object oriented mindset and sort of immersing ourselves in that. Um, cool, yeah. Oh yeah, misspelled submissions. Okay, that'll do it. Yeah, so so if you misspelled your repository, don't try to rename it on GitLab, right? There's different notions of the name of a repo, so I would just make a new repository and push stuff over from your source on your laptop or your Linux setup. Um, let's see, is a method functions inside the class or the class? Not 100% sure I get that, but a method is basically a function inside a class, and a class will typically have multiple methods, right, which are functions. And so our rectangle class had an area method and had a perimeter method and stuff like that. So yeah, it's the functions. It's not the class. And the class is the thing that holds the functions and the fields and the constructors. Yeah, and the terminology it does matter. Sometimes it seems like it's just words because people like words, but it's useful in Java because we'll use the same terminology again and again. So the class is kind of the whole thing. And inside here we find methods, and we find fields and constructors and stuff like that. And then you have an but this is just a blueprint, right? This is the design or blueprint for an object. And objects are like variables. And so from one class we can make, multiple instances of that object. So these are each instances of this class, right? And so we construct or we instantiate the class to create these objects. All right, let's look at command line arguments. So when we make our main program, we do this public static void main string bracket bracket args, right? It's our incantation, like integer main parentheses integer argc comma char star star argv. Same thing, but this is a little more meaningful in here. So let's see what exactly these command line arguments mean. So to be the main program of a Java class, right, it's got to be a function or a method named main, lowercase. It's got to be declared to return void. It has to be this keyword static that we won't talk about yet. And it has to take a single argument, which is a string bracket bracket. Okay, bracket bracket means arrays, just like in C. That is not Java. So let's just look at this first element in this array args and see what exactly it is. So I can compile up main.java, and if I say Java main, I get an exception, right? It says out of bounds exception 0 at line 4. I did question mark PP to get back to the PP. So question mark is a reverse search. Slash something looks forward for that, and then wraps question mark looks backwards. And I knew I had a PP in the beginning of the line, so I just did question mark. And then I did an X to delete the first P. Alright, so this is an array of arguments that you put on the command line when you run your program. I didn't put any arguments, I just said Java main, but I didn't list anything after here, so there is no args bracket 0. But if I say Java main, this is a test, it tells me args bracket 0 equals this. And so now we got a thing. So let's print out 4 arguments. And now if I run this with the command line arguments, this is a test. There they are. This is a test. So very, very easy to get your command line arguments out of your main program's declaration. It's just an array. And really argc and C is just an array, but it's a char star star, and it gets kind of muddled up. So here it's just an array in bracket 0, 1, 2, 3, and so on. So how do we know how many arguments we have? Because there's no argc, right? Well, we don't need an argc. It turns out that in Java, arrays are serious things, and so we can do this. We can say args.length. And that will tell us how many elements are in the array. So anytime you have an array, there's a dot length field, and that tells you the size of the array. And this is not a method. We're not calling length with parentheses after it. When we have a string, there's a method called length, and we call that with parentheses, and that runs some code that tells us the length of a string. But with an array, we just have this field called length, and we access it with just the name of the array, dot length. So string is a class. Args is an instance of that class. It's actually an array of strings. So it's an array of objects where each object is an instance of the string class. But string is a full-on class that, has all of this stuff, these constructors and these methods and so on and so forth. Alright, so string is a class. If we just said string args, args would be a string. If we say string bracket bracket args, args is an array of strings, so an array of objects. So args is an object, exactly. It's actually an array of objects. Cool, you got it. So if we Java C and we Java, it'll tell us the number of args is 4. So now we can do something a little more reasonable. So I'm going to print out args bracket, and I'm going to concatenate I, and I'm going to concatenate a close bracket equals, and I'm going to print out the value of args bracket I. So now this works, but we can give it any argument list that we want. Yeah, so this is super convenient, right? This will let us pass things to a program where we don't have to worry about argc, argv, and all of that business. And this is really useful, being able to see the length of an array, because we don't have to pass the length of an array as a separate piece of data. Why does anyone write stuff in C? Well, so Java is written in C, C++. It's closer to the hardware. It's arguably faster. It's more flexible. It's more powerful in some ways. And ultimately people write stuff in assembly language. Because in C, right, when you're writing Linux, you have to be able to interface with the hardware of your system to do certain low-level things like disk I/O and network I/O and stuff, and that is mostly written in assembly language. Yeah, so exactly, it's lower overhead. Because you don't need the virtual machine, and you don't need all that supporting infrastructure. Now C, you still need a runtime library, right? If you say printf, you still need a library somewhere that has the code for printf. If you say, scanf, you need the code for scanf. Assembly language, by and large, you're writing it as some kind of standalone thing. For example, a bootloader, you would probably write in assembly language, because when you boot up your system, you don't have most of, what you have in a running Linux system. You don't have the runtime library and so on and so forth. A pure bootloader might do something like send commands directly to a hard disk drive controller and read bytes off of a particular track to, load in the beginning of the operating system and boot up. And yeah, absolutely. The reason that we write C, right, in the sequence here is to learn about pointers and about memory allocation and about types of variables and converting from, strings to integers and all of that low-level stuff. We need to understand how that stuff works in order to be able to do things that we want to do with computers. So yeah, that is actually why we do it in the CS program. All right, so this is super fun, right? We have an array. We can just go ahead and say, okay, there's the length. So let's go on. Yeah, I've had people who have learned Java first and then tried to do C, and it's just super frustrating. It's like knowing how to do limits and then trying to do epsilon delta proofs for the first time. It's like, I already know what the limit is. Why do I have to do an epsilon delta? Well, if you already know how to use a linked list class in Java, why are you going to build a linked list class out of, sentinel arrow next equals blah blah? So yeah, there's different philosophies to it. I've generally advocated for doing things in this order. There are no strings in Python? Maybe that's my problem with Python. I like Python, I just haven't gotten very deep with it. All right, let's play with arrays in general. Yeah. On the other hand, Java is nice if you don't want to, get a computer science degree before you can write your first program. Java is a quicker entry in some ways. Python is way quicker, right? You can just, you can put your cat at a keyboard and come back in 10 minutes and you've got a Python program. So that's a nicer way to sort of introduce in high schools and stuff. But then, yeah, it makes it a little more challenging to go back to the roots of it all. All right, so let's look at arrays. All right, so there's a good old array. Nope. Oh man. time spacing. So arrays in Java. We've done some of this in C, right? Think about in C. Right, that's just an array of integers. And you can just declare this, and you can start using data bracket 0, bracket 1, bracket 2, and so on. But remember, if we had something like a struct, struct student star class, right? This would define an array of struct students. And we could malloc space. If we wanted a class of 100 students, we'd do 100 times size of struct student. Right? So if we wanted an array of structures, right, we need to allocate space for the structures themselves, or for pointers to structures. But then we had to do a second allocation. Right, we needed to actually allocate space for the individual structures inside that array. Right, so we had some assignment where we did this. And we're going to see something similar in Java. So, all right, so here's an array of just plain old integers. So let's make an array of squares. So we'll just set each element equal to I times I. And then let's print this out as a nice table. So I'm going to make a print method. So I'm just going to call this print. All right. So my print method is going to take an array of integers, so I'm just going to say int bracket bracket d. I'm not going to specify the length of this array, and I'm not going to pass in the length of this array, but the length is available. It's part of this array. So I can do something like this. Alright, so we'll just go through and we'll just print out the index and the element at that index. That would have been a nasty infinite loop. Thank you. I've been writing C all weekend, so. Oh, no, I don't want to get into this. All right, close your eyes. Okay, you can open them. Okay, I don't want to dig into statics. But let me just say for now, since I'm inside my main program and my main program is static, functions that I write in here have to be static also. But don't use the word static except for public static void main, right? You should not be writing functions in your main program Um, let me put it this way: in your fraction class, don't use the word static. Okay, if you're finding problems, if you're getting compile errors that mention the word static, don't start lobbing the word static into your fraction class to try to fix it, because you will get more and more tangled up in a web. Um, but I'm putting a function inside uh, my main class, and I'm calling it from a static method, so it's got to be static. But ignore that, right? Don't worry about it. All right. Whoa. Yeah. So I'm teaching by counterexample this morning. So yeah, if you're making a class in a file called main2, make sure your class is called main2 also. All right. So there's an example of passing an array. It's easier than all of that. Let's see. Looking at chat here. I wish I had some of my old basic programs, man. Yeah, first programs are awesome. Definitely hold on to those. Shouldn't be disgusting, because it's like, I mean, this is our learning, right? W3 schools, yes, cool, thank you. Yeah, int bracket. Printf does not work in Java. There you go. Yep. Page after page of if else. Yeah, that's okay. All right. So this is, declaring an array of integers, and we're putting some values in. If we want to pass it to another function, a method, we just pass it, right? We just put in the name, and we can pick it up and just declare it as an array, and we can get to its length with the length field, and we can access elements in the usual way. And if I make it an array of 20 characters, and I only initialize the first 10, they seem to end up as zeros. All right, let's see what we have in here. Well, I'll play with fractions just for fun, because we already have fractions here. Let's make an array of fractions. Let's see, could you do this by passing it like data.print? So data doesn't have a field or a method named print. Data is just an array of integers. So data.print won't work. But if this was a bona fide class that I had created for arrays of integers or something like that, I could give it a print method, and then I could say data.print paren, and that might be the thing that prints out the table of values or something like that. So yeah, that would be something that we would build into the class, and then we could just call the print method. All right, so let's make an array of objects. All right, so same thing as with integers. I can say class name bracket bracket variable name equals new class name bracket, however many of these I want, right? And by the way, we can do this like this. Or we could do it like this, right? Either way is the same end effect. So this is declaring data to be an array of integers, but it hasn't actually created that array in some sense, right? It hasn't done the malloc. And so here we're basically doing the malloc. We're creating the space for the 20 integers and setting data equal to that. So you can kind of think of that as sort of like malloc. All right, so here we're going to do the same thing. We've got an array called myArray of fractions. That's the declaration of it. I'm also doing the malloc, the memory allocation, the construction of those fractions, right? So now myArray is a bona fide array of 10 fractions, but let's print out the first element of that array. Right, and it tells me it's null. Right? It's null because even though my array is now an array of 10 fractions, those fractions in the array have not been constructed yet. Okay, we've created an array of fractions, but those fractions don't exist. And this is what happened to us in C. We would create an array of struct nodes, right? Pointers to struct nodes, but they weren't pointing anywhere in particular. I don't know if you remember that. All right, so this will get us into trouble. So if I wanted to print out myArray bracket 0, multiply new multiply by by 2. All right. So what am I doing here? I'm taking my first element in my array, which is a fraction. My fraction has a multiply method. I'm calling the multiply method with an argument of 2. That's 2 as a fraction, so new fraction 2. And this should print out my first element in the array times 2. All right, but I get an exception. Right, I'm getting an exception because this fraction is null. It doesn't actually exist yet. So making the array creates 10 slots, right? And each of those slots can hold a fraction, but the fractions still need to be constructed individually. So I would need to do something like myArray 0 equals new fraction 5/2. Now that first element in my array is a fraction, and so that first element in my array has a multiply method, and I can call that with a 2, and I can print that out, and I should get a 5. So if you construct an array, those fractions are null to begin with. They're kind of initialized to null. But it's probably more correct to think of them as uninitialized in some way, or more useful. All right. So we'll refresh this as we go forward, but that's the basic idea of arrays. So you can declare an array with, int bracket bracket. If it's an integer, we can just say, new integer bracket 20. But if it's something like a fraction, we have to do more than that. We also have to, construct the individual fractions as well. And this gets into a notion of primitives. And you'll hear people talking about Java say things like, everything is a class in Java. And that's almost completely true. But there are a few exceptions. So there are integers, there's characters, there's floats, there's doubles, there's bytes, there's booleans, and I think there's one more that I always forget. But these things are called primitives, and they start with a lowercase letter, which is significant. And they let you do things like, say, integer x equals 5, without having to use the new keyword. Now, if int was a class, and I wanted to make an integer, I would have to do something like integer I equals new int. And then I could say I equals 5. Right? For a fraction, this is exactly what I have to do. I have to declare that this thing is an object of type fraction, and then I have to construct it. But this would be really unpleasant if we had to do this every time we made an integer, because we want to write I equals 0, right? That's how you start every program. So we don't have to do this. Integers are a special type of variable. They're what's called a primitive. And they're actually, the integer class underneath, but we can just say integer I, and immediately we've got an integer. It's got space allocated to it. We can give it a value. We can print it, and so on and so forth. I don't know if short or long might be one of those. So byte is like a short int. That's an 8-bit deal. Long sounds plausible. I'm just gonna cheat. So primitive types in Java. Yep. Oh, short and long. You are absolutely right. So there's 8 primitives. I didn't realize that. Awesome. Good job. So integer, byte, short, long, float, double, boolean, and char. Okay, cool. All right. So we have these kind of convenience types that we can use the same way that we use them in C, for example. But everything else is a class. And so, for example, there's an integer class. And, it's an integer with an uppercase I. And we can construct an integer by saying something like, uppercase integer I equals new uppercase integer parentheses and the value we want that integer to have. They're called primitives because, yeah, they're not objects in the usual sense. They're something more rudimentary. We can't access the integer methods from a primitive int, right? They're lower class, yeah, and they're lowercase. All right, but an integer, right? Integer is a class, and if we declare an object of type integer, then we have all these methods available, right? For example, we can count how many bits in the representation of that integer are a 1. Right? Why is that useful? Well, that's nice if you want to generate parity, for example. We can compare 2 integers, right? This gives us, we can take in 2 integers and get their value back. We can tell if an integer is equal to another integer. We can convert an integer to a float, and so on and so forth. And, you know, integers in C are just, you know, integer I, int I. In Java, they have all of this stuff, including, you know, our favorite toString method, which returns a string representation of the integer. And so we'll you know see the evil static word pop up here. We're still going to ignore that for a little while, but we can do things that we like to do with integers using the integer class. Actually, I'm just going to talk about statics right now, because there's no need to dance around them. We've talked about classes and objects, and you've had a few days to contemplate those. So let's talk about statics. So it's really not that big a deal. Let's think about a class rectangle. And we know we can put methods inside here, and we can put fields inside here. So, you know, I could have integer length. I could have an integer area, and so on and so forth. Oh, that's a good statics joke. And so if I make a rectangle, right, I construct a rectangle, I give it some dimensions and so on. If I say something like r.area, right, that makes perfect sense. We know exactly what this means. It means use the area method of this object r, which is an instance of a rectangle. So go ahead inside here and run all the code in that area method, right, using the values associated with this object r. Okay, that all makes perfect sense. Suppose you have a function inside your rectangle class, though, that makes sense without having a particular rectangle. So suppose, well, let's talk about math. Right? So there's a math class, and you can create an object of type math and do various things with it, right? But one of the things that's useful to be able to do is to compute square roots. And square roots are part of the math class. So there's, you know, a method called square root, which returns a double, which is the square root of something. If we really stuck to this idea that everything is a class, and I wanted to take the square root of 2, what would I have to do? I would have to do something like, you know, math2 equals new math2, and then, you know, y equals 2 dot square root. That would be weird. This is not something we want people to have to do, right? We want to use this method inside this class, but we don't want to construct an object of this type just to use this method. The square root function really makes sense as a function that you pass an argument to and you get a result back. And logically, you know, a function like square root probably belongs in a class with a name something like math. But really, to do a square root, I just want to say something like, you know, double y equals square root of 2. So I'm going to put a math dot in front of square root to tell the system where do I find this square root method. But I'm not going to use the name of an object of type math. I'm actually going to use the name of the class math. So I'm going to say math uppercase m dot square root. This is a class name. When I do x equals r dot area, this is an object. And so far we've been talking about methods. This is what we've been doing. We've been using an object, period, the name of a method. So this is called an instance method. It's a method that we run as part of some instance of a class. Rectangle is a class. R is an instance of the class. It's an object, and that object has an area method, so we call this instance method, r.area. But here, we're going to use the name of the class itself rather than the name of an object, math, and we're going to call what we can name a class method. It's a method that we don't need a particular object for it to make sense. Now, if I tried to call rectangle.area, that would make no sense, because what rectangle am I going to find the area of? What length and what height am I going to use? But square root, if I define this as a function that I pass a double and it returns a double, makes perfect sense. I don't need a math object. So if we look at the documentation for math, I just closed a window I shouldn't have closed. I have no idea which one. If you look at the documentation for the math class, you find all these methods that are defined as static, including the object of our attention right now, square root. So when we want to define a class method, we use the keyword static. Okay, and that's the whole thing that static does for us. So static in the declaration of a method or a field means it's going to be a class thing, a class method or a class field. So square root we can just run as uppercase math dot square root. And similarly, there's a field in the math class called pi, and we can say math dot pi, and that gives us the value of pi. Yay, okay, good. Yeah, I forgot to make people take the oath. Alright, so there's a math.pi and a math.e. And so in your fraction class, when I said return double.nan, what is nan? Nan is just a static field in the double class. So if you say uppercase D double dot nan, it returns this particular value, which is, you know, this 64-bit number that under the IEEE 754 standard corresponds to not a number. All right, so that's the first pass over statics and static methods versus instance methods. But my advice from the beginning stands, right? In your fraction class, you should not have to use the word static. The only time that you might have to use it is if you're writing a main program. I'm just closing windows left and right. If you're writing a main program and your main, which has to be static, is trying to call a method inside this main class, then that method's going to have to be static also. But mostly your main programs are going to be probably relatively simple drivers for the classes that you're developing. So I don't think you'll have to use a static anytime for PA1. And so we'll work with this more by the time we get to PA2. All right, we are out of time. I will leave it there for now. Keep working on fraction class. Come by office hours if you have questions, and I will see you tomorrow.